Hello, good morning, welcome. Welcome to TypeScript, JavaScript Evolved. My name is Jess Chadwick. Among few things that I do, I'm a Microsoft MVP and also one of the hosts of the Static Void podcast, along with Chris Gomez back there and Todd Snyder, one of the other speakers today. So if you listen to podcasts, check it out. Love to hear your thoughts. I also am the author of TypeScript Essential Training on LinkedIn Learning /lynda.com, same thing. So this session today is actually kind of a compressed version of this, big long course. The course is like 3-4 hours long, and so this is just kind of a intro today. And so if you find this interesting, feel free to go check out that course. Or when I created that course, I literally scripted out word for word, including the sample code snippets and everything. And so when I was done, I just kind of put that into a book, and it's free. So you can go to leanpub.com/essential TypeScript and get the free ebook on there too if you don't want to pay for LinkedIn Learning if you don't already have a subscription. So enough with the sales pitch. What is TypeScript? So let's just start with the basics, the fundamentals. TypeScript is a couple of things. So coming into this, if you've heard about TypeScript before, you probably think of it as a language, and that's true. It is a language, but it's also when we jump into the command line and we go and we kind of compile that language, TypeScript is also a transpiler, which means that it takes the code that you're writing and transpiles it, converts it into code that runs on browsers everywhere, right? And so we see these concentric circles right here, and the smallest one represents the circle of features, JavaScript features or ECMAScript features, that are widely available, widely supported, widely available out in the wild today in the most browsers. Outside of that, we have ES current, ECMAScript current. So I don't know how many of you are aware of this, but ECMAScript recently, over the past couple of years, has actually switched to a yearly schedule where they have, every year they go through a process of people can kind of submit feature requests or things to come into the next version, and then every year they release a new version. Because for a while there was about 10 years where we didn't have a new version of ECMAScript/JavaScript. And so now it's a yearly cadence, and so every year you maybe have a couple of new things that come out. And so ES current is the last thing that was officially released, the last ECMAScript standard which was officially released. And now just because it's released doesn't mean it's actually widely supported, it's actually implemented, right? So there's still a lag. And then above and beyond that, there's that third circle, there's that outside circle, which is ECMAScript futures, the stuff that's coming in the future, maybe in the next release, maybe way out, right? And these are proposals that have not necessarily been accepted. They may be various stages of maturity or acceptance. And so what TypeScript allows you to do is it is a transpiler. It allows you to use all three of these things, right? Obviously, you can write just regular JavaScript. That's the thing that's widely supported. It also allows you to take advantage of the ES current features and maybe even the ES next features and then transpile them down into code that will run on all of the browsers today, along with polyfills or whatever, right? Either by rewriting your code or including polyfills, however it does it, and it does it differently depending on the actual feature, it transpiles your code down. So even if you don't take advantage of types, which is the real value that it brings to the table, you can use it as a transpiler. Now, if you're just looking for a transpiler, there's plenty of other alternatives out there which are arguably better at transpiling. If transpiling is all you want, the most popular one is Babel or Babel, depending on how you say it. But TypeScript, and there's a chart somewhere on the internet that kind of compares all the features and the support between the various transpilers. TypeScript has very, very good support, very close to what Babel supports in terms of the futures and current features that it supports as a transpiler. But what we're really looking for in TypeScript is strong static typing. So it takes all of that, all of the ECMAScript standards that are out there, it implements those through transpilation, and then it adds types. So what are types, or why do we want to use types? How many of you are C# developers, or at least, yeah, right. It's a .NET conference, right? And so I don't have to sell you on the benefits of strong typing, but just to kind of get everybody on the same page, this is what we're looking for. This is why we use C#. This is why C# is a strongly typed, statically typed language. And it's the benefits that you get by applying strong and static typing to JavaScript. So first and foremost, you can catch those errors at compile time versus runtime. right? So if you make that spelling mistake, which is what most bugs come down to, especially in JavaScript, the compiler can find it at compile time, not when you're actually live in production, right? You also get better tooling, refactoring, autocomplete, and everything. This one was, maybe still is, a little kind of contentious. People will say, but my editor of choice has great JavaScript autocomplete, right? In other words, when I type in a class name or a variable name and I say dot, I get a long list of options. The difference is that TypeScript is smart enough to say, when I say dot on any given variable, and I get that list of options, TypeScript is smart enough to say, no, these are the only 3 things that are off of this variable that you're looking at, off of this object, right? Versus the several thousand things that I found by looking at all the other properties or fields among the objects that I saw in your project, right? So yes, those 3 things may be in that initial list of 3,000 that your other editors can give you, but TypeScript kind of narrows it down and makes it even better. This is also kind of funny because it kind of ties in with the first one, where if most errors, especially in JavaScript, are due to misspellings, the autocomplete in the other browsers that are, or the other editors that are not smart enough to figure this out, once you misspell it once, you can actually easily misspell it over and over and over again, right? Because that's, the IDE actually encourages you to do that. My favorite thing is the last one, though, explicitly expressing your intent, right? So in JavaScript, JavaScript is a beautiful dynamic language. You can do a whole bunch of awesome things. You can take advantage of the dynamicness, the dynamic nature of the language. And in fact, sometimes when you jump to JavaScript and then jump back to C#, you're actually kind of frustrated. Like, well, in JavaScript, this would just be easy, right? But in C#, I have to create an interface and then derive from that. But, you know, do a whole bunch of stuff just to do something a little bit dynamic. Whereas in JavaScript, it's beautiful. But in JavaScript, it's also, when you're doing this dynamic stuff, or if you're getting a little bit crazy, it's hard for you or the people on your team, when they come in 3 months from now, to look at this piece of code and say, well, what's going on here, right? It looks like it's supposed to be a string, but then like it's assigned to a number later on, and and so when you apply strong static typing, you very clearly say, I want this variable to be of a type string. I want this method to return a number value or Boolean value, and you're stating that, right? When I first heard about TypeScript, I immediately just wrote it off, completely wrote it off. I love JavaScript so much, and particularly the dynamic nature of JavaScript and what it allows you to do. I was just completely skeptical. I wrote it off. Now, as Chris will tell you, and plenty of others who have seen my talks, I'm a fanboy. I mean, I'm not a fanboy of much. I think TypeScript is probably the only thing that I'm a fanboy about, because when I first heard about it, I was very suspicious because JavaScript is so beautiful, it's so dynamic, and when I heard about it, I initially thought that you want to take that dynamicism away, that dynamic nature away, right? Those dynamic abilities away. And my immediate reaction was just no, right? And this is pretty much the reaction that everybody that I've talked to, literally everybody. I mean, I'm one to, exaggerate, but I think literally every single person that I've talked to about JavaScript, their initial reaction was, nope, I'm not doing that, right? Until you realize a couple of things. The first one is type inference. So TypeScript uses type inference. One of my favorite things about TypeScript, especially getting started, because whenever I give these talks, I always like to kind of focus on what can you go back to on Monday morning and start doing Monday morning, right? And so if it's go and download this big framework and then convert your whole team over and everything, that's never going to fly. But Monday morning, what can you do? My favorite thing is that you download the TypeScript compiler and you rename your JavaScript files, your .js files, to .ts. Because of those concentric circles, because TypeScript is JavaScript, it's a superset of JavaScript, all JavaScript, by nature, is valid TypeScript. And so you're already there. You're already writing TypeScript, and now you can start applying types and take advantage of all that. But what type inference does is you don't even need to start applying types. Just simply by converting it to TypeScript and running it through that TypeScript compiler, TypeScript will go in and it will look and it will say, hey, here's a piece of code. I've got 2 variables here, y and x, right? I'm assigning y to a string. So y must be a string type. I'm assigning x to a number, so x must be a number. And then on line 3, this is existing code, I'm reassigning y to X, right? This is existing code that works today, that's running out in production today. TypeScript is going to say, nope, this is an error. And so while this is a good and bad thing, this is also a perfect example of why it might be a bad thing in terms of initially applying TypeScript to your existing projects, because maybe this is code that is running out there today that you intended for that to happen. Or maybe TypeScript just found a bug for you, right? Just by renaming it, it found a bug. If it is the case that you actually wanted to do this, this was deliberate, there's also, TypeScript also supports gradual typing, which simply just means that you can tell TypeScript to butt out. You can opt out of the typing system anytime you want. So by default, it uses that inference. But you can use the any keyword, the any type, to tell TypeScript, nope, I want to go back to that true dynamic nature of JavaScript. And there, you're basically opting out of the type system. You're dropping back down into kind of classic, pure JavaScript, and you're back to where you were. So I have at the end, yay, I made it work. I made the compiler error go away. Maybe that is a good thing. Maybe it isn't. From this snippet of code, it's literally impossible to tell whether I actually intended for that to happen or not. But in the case, assuming that I did intend for this to happen, that this is actual code that I wanted, then applying that any allows me to use TypeScript in the rest of this file, the rest of the application, and still kind of get away with this stuff. I've only got a couple more slides, and I'm going to spend the rest of the time in code. TypeScript also allows you to do object-oriented JavaScript. So quick show of hands, a quick poll. Is a JavaScript object-oriented? Yes. Anybody yes? Yes? No? You see the nose? Kind of. Yes. So I think the real answer is that no, but it pretends to be. It can pretend to be, right? There's a lot of syntax. There's a lot of sugar on there. Especially in the recent versions of TypeScript, the ECMAScript, ES6, and so on, that actually add the class keyword, right? That make it look like a whole lot like C# and objects, right? When you're making a class, you're building a contract for an object, right? But underneath it all, it's still just functions. So JavaScript is a very functional language, but on top of that, you can kind of put object-oriented metaphors on top of it. The reason I include that slide is just to call out that TypeScript does that, right? By bringing these types in, it brings a lot more of a feel of object-orientedness, regardless of whether JavaScript is object-oriented or not, right? It kind of allows you to work with it as if it were. This is what I like to call TypeScript in a slide. And I'm just going to kind of leave this up here for a minute. I'll talk you through it a little bit and point out a couple of things. The reason that I put this slide up is basically I'm not going to go through the fundamentals of the syntax. This is the fundamentals. And we all raised our hands to say we are C# developers. So if you know C#, the syntax is going to make a whole lot of sense to you, right? I also want to point out that TypeScript was released in 2012. I did this talk for the first time in 2014. I haven't updated these slides since then. I don't really need to. There's been more features that have been added to TypeScript. There's been more features that have been added to JavaScript in that time, but also to TypeScript. But the fundamentals stay the same. And so if you use nothing more in TypeScript than just these fundamentals, you're already winning. The one exception here is that this module syntax has kind of fallen out of grace. The reason that I did not update this slide is to appeal to .NET developers like yourself, right? So the whole point of this slide is to kind of say, you're used to C#. Let's look at the similarities to C#. So I've got interfaces, right? I've got interfaces. Interfaces describe a contract. So I create an interface called iAnimal. iAnimal just defines I've got a field. And this is how you assign a type or apply a type is with the colon and then the type name. So there's only a couple of different types in JavaScript. And TypeScript doesn't add any more. It may kind of define more through its typing system, but it doesn't add anymore, right? You're still not getting away from the fact that there are strings, there are functions, there are void, there are, what am I missing? Array is not really a type, a special type, but there's only a handful of actual JavaScript types. But what TypeScript does is it allows you, through uses of interfaces and classes, to kind of define your own, and really give that that strong sense of typing. And so now I've got class. I implement a class here, right? So we see class animal implements iAnimal. So you implement an interface. Over here, you extend, where's my, there, over here, the dog, you extend a base class. You implement an interface, you extend a base class, right? So in C#, this would just be a colon for either of them. In TypeScript, you need to be a little bit more explicit. Once you get into that class definition, we've got these private fields. Can you make a field private in JavaScript? Anybody? No? Not really, not really. I mean, the way that JavaScript works, you can do tricks like creating closures and everything, so you can really kind of protect it and encapsulate it and keep other people from getting into it. But ultimately, there's no real such concept as private in JavaScript. TypeScript doesn't change that. Despite what this says, TypeScript doesn't change that. These accessors, the private, protected, internal, all they do is provide metadata. And so this is when you have a TypeScript file and then you're consuming it from another TypeScript file, and you try from over here to access a private field, a private method or whatever in this class, from this class, TypeScript is going to say, no, you can't do that. Even though it'll continue to compile it down and you can run it and it will work. From a technical standpoint, it will run, it will work, you can do that. JavaScript allows you to do that. TypeScript is going to give you an error and said, you said your intent was for this to be private and not be accessed. So I'm going to yell at you when you break that intent. Right? So that's a big example of intent, expressing intent, regardless of the actual implementation. Then this is not exactly how we do properties in C#. This is more of Java syntax, right? Getters and setters, but ultimately get property, set property to a private field, right? Then we have a constructor, right? Constructor can take in parameters, and this one just assigns to the setter here, which then just assigns to the field. Very simple. And we have a method, right? A method. And then we've got template strings. How many of you are familiar with template strings in ECMAScript 6? So this is actually in ECMAScript 6. So when I first made this slide, a whole bunch of this stuff, pretty much everything on here was just in TypeScript. Now ECMAScript actually has a lot of this stuff, including the class, including the template strings, which are awesome, probably my favorite feature. But what it doesn't have is interfaces, private, and then everything around this type system. So then we go on to the right-hand side and we start using this animal class, right? We extend it, we create a dog, and we add another method on there. The module up there, I said it's fallen out of grace, but it really kind of applies to our namespaces, what you think of a namespace in C# and .NET. The reason I left it on and the reason it's kind of fallen out of grace is because, generally speaking, today, a module is just a file. And you'll import whole files, and that'll kind of be your container. That will be your module as the file, right? So this is still legitimate syntax. You can still do this. It still works. It still compiles, but you're just not really going to. You're just going to create a class named, or a file named dog, and put your class in there. The other reason I left it in there is to show this casting down here, this syntax down here, right? So here's where I actually use this stuff. I created a class, a base class. I derived from it. I created a dog. Now I'm using it. Create a variable, and I just say that if that variable is that interface. It's the iAnimal interface, right? So it can be anything. And then I assign it to a dog using that kind of namespace or module.dog syntax. And then I call the method on the interface, on the animal interface. And finally, that very last line is a screenshot of the Intellisense that the editor has given me. This is an example of what I was saying earlier. I'm not getting that list of 3,000 options, right? It's saying these are the only 3 things that you can do. And this is not an edited photo. This is literally a screen cap from the IDE, from Visual Studio. This is saying these are the 3 things that you can do. Because you've casted it to a dog, you can now also say bark, right? If I were to say dot up here, I would only get name and say name. Any questions? I'm not going to have a whole lot of time for questions, but this is the fundamentals and, okay, cool. So that you may, let's just get into it. I'll get into the code, and it'll probably answer your question. Yes, I will. All right, so what I've got here, I've got an existing app already. This is Visual Studio Code, so let's talk about kind of the tooling that you need. I've got two things. I've got my editor. You don't see my editor. Come on. Stupid PowerPoint. There we go. All right, I've got my editor, and I'm going to drop to the command line a little bit, and I'm going to run Typescript, the Typescript CLI from the command line. I happen to be using Visual Studio Code, the Atom text editor. There's OK support in Visual Studio. Ironically enough, Typescript is from Microsoft, but yet the TypeScript experience embedded in Visual Studio leaves a lot to be desired. It's gotten a lot better recently, but it leaves a lot to be desired. So especially for simple demos, I prefer to use Visual Studio Code. So this is an existing app, and I mean, I can run the app, but it doesn't even really matter what it does. But it's basically, it's a to-do application. Let me just go ahead and run it. It's a to-do application. It's a to-do list, right? I mean, you can do stuff, add to-dos. There you go, right? So now, when I come in, and I click my button, it's actually broken, right? So I've got an error in here, deliberately. I've got a bug. The reason I put this bug in, you can see down here, to-do service clear complete is not a function, because this is one of those things that right now I have no idea. If I open up, the bug is actually in this file. If I open it up here, everything looks good. But as soon as I convert this to TypeScript, TypeScript is going to say, hey, there's your bug right there, right? So I'm just going to go and I'm going to convert this application to TypeScript. So I'll kind of walk you through the thought process and what you need to do. So we'll start. I've got two classes. I've got this to-do service. This is just the thing that manages my to-dos, right? So I've got things like add a to-do, clear completed, delete, get all, right? It's basic CRUD operations, but all of my logic for managing to-dos happens in this service. I've got the to-dos on my server, right? I've just got a JSON file, and then I've got the actual app, which is just jQuery. One of the first things it does is it goes and it grabs that JSON file, creates a new instance of the to-do service, and then kind of wires everything up for jQuery, right? So very simple, very kind of clear, straightforward. So let's just go ahead and start converting this over. So I very deliberately, you may or may not write your JavaScript in this way. This is kind of one of the standard ways. There are several of them. So there's a couple of things going on here. So you'll see I'm creating this to-do service class in here using kind of the traditional JavaScript approach, like the ES5, before the class keyword came into ES6. And I'm creating everything inside of a closure just simply to prevent leakage. So if I accidentally create a global variable in here or something, it's not going to leak out. It'll stay within this function. And then at the end, you can see I start here with this, and this whole thing is what's called an IFI, an immediately invoked function. And so at the end, I just call it, right, which executes this script, returns the thing that I built, that to-do service that I built, and then I assign that to a global variable. Then that's what I use over in my app, right? And I knew it up. So we start off when we're building a class in JavaScript, even ECMAScript 5, when we're building something, it's really just a constructor function, and then we use the prototype to add behavior onto each new instance of that thing that the constructor function creates, right? And in this way, this is kind of how we define a class. There's also, you can define a property, as I've done here. Everybody can see that? You also can define a property directly onto that function, which is effectively what you would think of in C# as a static property. So there's one instance in the entire application. And so if this is a class, let's just go ahead and start converting it, right? So the first thing we're going to want to do is we're going to want to, because this project doesn't have anything to do with TypeScript right now. So we're going to want to kind of prep the project by creating what's called a tsconfig file. This is This is the configuration, the TypeScript configuration for this whole project. So this is where I kind of define my properties and everything. And since Visual Studio Code has really good TypeScript support, I actually get Intellisense on this configuration file here. So I just, even though it's just a JSON file, it knows that tsconfig.json is a TypeScript configuration. So I'm going to go in, I'm going to go to compiler options, and in here I've got a whole list of compiler options. One of these options that I'm not going to get into, I'm not going to show, is actually allow.js, which is allow JavaScript files to be compiled. This is another cool thing when you're just starting out. You can say, this file is a TypeScript file because it's a .ts, but then run the JavaScript compiler against all my JS files too, just to help me find other stuff. So even though I'm not going to put typing and everything on there, you can use the type inference just from the JavaScript files, plus the types that I do create and I do define in my TypeScript files and apply them to the JavaScript files. So you can kind of have that best of both worlds. So you can take your time converting your project over, right? You've got thousands of JavaScript files now. You can start and just kind of do them one at a time and take advantage of that in the rest of the application. The one I'm really looking for here is target. So this tells TypeScript what level, what version of ECMAScript are you targeting? And so I've got a variety of versions that I can choose. ES 2015, ES 2016. So I'm not sure how many of you are familiar with this, but when they converted to that yearly cycle, they went away from the ES5, ES6, that version, that major minor version, and they moved toward the yearly version. So ES6 is ES 2015, more or less. And then from then on, there was no ES7, ES8. It went to 2015, 2016, 2017. So we are going to target today the most broadly, widely supported that you can pretty much guarantee is going to be on every browser. We're going to target ES5. And so that's not going to have any of that stuff that I showed in the slide earlier with those constructors and those templates and everything. Those are all things that TypeScript is going to have to kind of fill in for us. So once I've got that in place, I just save that. I just go and I rename, because JavaScript is TypeScript, I rename my TypeScript file. I rename my JavaScript file to TS TypeScript. Right away, it's going to give me one error. And in fact, depending on your editor, you're going to see this. tsconfig, it's already also yelling at me that I don't have any inputs, but the inputs are implied, I think. I'm using this property ID. If you can't actually see the error, that's fine. It's yelling at me because I defined, even though this is kind of the legitimate way to define a static property, it's already yelling at me to say that, hey, you didn't define this property or this field on this class before you assigned it. You're just going and assigning something that I don't know about, so I'm going to yell at you. Regardless, and this goes back to the idea of easily getting up and running in your project. Regardless, TypeScript will compile this application anyway. So there's different classes of errors. Some of them are just completely catastrophic, and TypeScript says, I'm not going to render this file out until you fix this error. Like, you can't move forward. Others, they are errors. They show up as errors in your compiler, but TypeScript says, well, I'll still compile anyway. Right? So this kind of goes along with, at least I don't like any errors. So I'm always going to clean up the errors, but you don't have to for a certain class. So now I'm jumping to the command line, and I use TSC. If you can't see this, it doesn't matter. TSC, and I'm giving the -W flag, which means watch. So this is going to run, for the rest of the talk, I'm going to minimize this, I'm going to close it. This is going to run TypeScript in the background. It's going to be watching my files. As I'm in the editor and I'm saving, it's going to run again and regenerate those files, and we'll see the output. So when I hit this, watch my Visual Studio Code project, it's going to generate. It's going to take those TS files and it's going to generate, despite the fact that it's giving me errors, it's going to generate this JS. So I've got that new JS file in here. I'll open that up. See if I've got enough real estate to keep this open. Maybe I'll just be going back and forth here. Let's see what it produced. Because I did kind of canonical ES5, it basically just copied everything over. There's a couple other options. So like I want to do, even though I'm going to use, TypeScript isn't a minifier. You don't really want to use it as a minifier, but hey, let's just say, let's get rid of those comments while you do this, right? I'm going to minify this again later anyway. But let's get rid of those comments. I think if I just save this again, I don't have to restart. All right, well, let's restart that. There we go. Get rid of those comments. Oh, yeah, I didn't change the TypeScript file. That's why. Cool. So we got rid of those comments. So now I'm going to make a couple of different edits, and I'm going to kind of upgrade this into a TypeScript class. And as I save, you'll see on the right that it'll just kind of update, and you'll see. So first thing I'm going to do, I'm going to rename this just so I can let it live for a minute and it doesn't get in the way. And the first thing I'm going to do is I'm going to say class to-do service. So the same name of the class. I'm not going to implement an interface just yet. And the first thing I'm going to do, because TypeScript is complaining about me to me about this static, is I'm just going to move that over here. So a static property looks like this. That's a regular property. C#, right? Like when in doubt, what would you do in C#? Go ahead and try it out, right? So you just say static. So this is a non-static. This is a member property. This is a static. This is a static property. And again, like I showed in the slide, you can say private, protected, whatever, right? You can apply that. So as I do this, we can see the regenerated stuff on the side. And you can see, even though TypeScript was yelling at me because I did it, when it transpiles it down, that's the right way to do a static, right? So it's going to do that. Now I can keep moving down, and I can look at this constructor, right? So this is the constructor method. I'm just going to copy that in. And instead of function to do service, you literally just say constructor. Now this will work. Minimize this again. So now it's yelling at me a couple things. Obviously, right now it's yelling at me, well, you don't have a method called add to do. That's fine. We'll take care of that in a minute. This is also saying, again, perfectly legitimate JavaScript, but it's telling me, just like with that static property, you're trying to use a property that you haven't defined yet. And so I'm not going to let that happen. I have no idea what this is. It does not exist, so that's an error. So you have to define it. So that's fine. I'll just create my members property. And what the heck, I'll do it. I'll make it private as well. To-dos. And then I just leave it like that, right? And then TypeScript is fine. When I save this, we can see this is updating over here. Nothing's really changing. There's a shortcut. There's a very cool shortcut that TypeScript provides as well. As you pass in these constructor parameters, if I were to do something like this, right, if I were to do something like this, basically just take that thing and just assign it to a private field immediately, there's actually a shortcut that TypeScript provides. I can say, just put an accessor, any accessor. It doesn't have to be private or protected or whatever. This basically says, because it's yelling at me, duplicate identifier, this creates the field. So it is both a constructor parameter and a field, just by kind of decorating like that. That's not what I want to do here, so I'm going to get rid of all this. Because what I'm doing, if you look at this code, is I'm taking in a list of, and if we look at this, these comments on the original one, the constructor takes an array of to-do or string objects, or both. So it takes an array of objects. Each individual item in that array can be either a string or a to-do. What's a to-do? Right? I haven't defined that yet. So let's stop for a minute and let's do that. Let's define what a to-do is by defining an interface. So now as I do this, watch on the right-hand side. When I created this class to-do service, it actually generated code, right? As I create an interface to-do has a number, it has a name, and it has completed. Is it completed? Yes or no? That's a Boolean. When I save and this regenerates, it regenerated, but nothing happened. Because the very first thing that TypeScript does, it reads all that typing information that you gave it, and it just strips it out, just throws it away. Keeps it in memory, and it applies it, but it throws it away out of the final product. So any interfaces, any of these type definitions, so now I can say, all right, this is an array of to-dos, right? And again, I can save, watch the right, nothing happens because the type information doesn't actually go down to the browser. I can also say, this is an array of either to-dos or strings, right? This is not something you can do in C#. This is kind of calling back to JavaScript. In JavaScript, that's totally legitimate, that you can pass an array of anything and figure it out as we go, which actually the implementation of add to do takes advantage of that, which we'll see in a minute when we implement that. So the next line of this initializes the to-dos, right? That's what this is doing. And so I can do it like this, obviously. TypeScript's not yelling at me, but the shortcut here is that I can initialize it just like in C#. I can initialize it in the declaration, right? So if I save this, again, watch the right. Nothing's going to change because the implementation is still the same thing. The first thing that you do in the constructor is initialize all of these default values for the properties, right? There is no such thing as something coming before a constructor function call over here. Right? Does that make sense? So it just kind of moves it, and it continues to initialize it here. Likewise, for typing, this private list is a list of to-dos, not to-dos or strings. That's what the add to-do function does, is it converts any strings into to-do objects, as you'll see in a minute. So before we get out of this constructor, let's handle this one other thing. How many of you have used this approach? How many of you have created underscore this or self or me or that or whatever, right? So this is what you need to do. For those of you who haven't done that, this is what you need to do in order to get a reference to this inside of another function, inside of a closure, right? So if I were to just do this, you are never sure what inside of this function, you're never sure, you cannot be completely confident what this will refer to when that function is actually called, right? And so in order to make completely sure, you need to do something, right? You need to save it to a variable. The name of the variable is irrelevant, completely irrelevant, but you need to save it to a variable and then reference that variable inside of that function. Now, I generally don't. This is one of the exceptions where I would never use underscore this. That's just a stupid name. But the reason that I did it is because what TypeScript, and now ECMAScript 6, this is an ECMAScript 6 function. So in other words, this is what we really want to do. And what TypeScript provides us, ECMAScript 6, is the idea of arrow functions, or in C# we call them lambda functions, lambda expressions, right? So I remove that, let's play that again. I remove function, and I replaced it with an arrow. So it's still a function, but what that does is it captures this variable. So now this does actually refer to this instance of the to-do service. Because when I save it and we compile it down and we see what the ES, you saw it jump, the ordering jump, that's because it saved it recompiled. The variable that TypeScript happens to create is underscore this, which is why I named mine that as well. But when TypeScript compiles it down to the standard function, the ES5 function, right? Because these arrow functions are not supported in ES5. So it will take care of that reference, it'll compile it down, change it, and render something else out, right? So it creates that correct enclosure. So in this way, arrow functions are really just syntactic sugar at this point, but they're really, really, really nice. So let's go. I swear I'm not going to convert this entire class. I'm just going to do meaningful ones. So now let's make TypeScript happy by implementing this add to do. So I'm deliberately kind of going and copying and pasting. I'm not really explaining everything as I do it, but I'm deliberately going and copying and pasting because these are the steps that you're going to take when you're converting your existing code over, right? And so when I convert a method that is declared in this way on the prototype, right? You say, I got my prototype, and then I want to add something onto it, a function, a property, or whatever. This is the syntax that you use to do that in ES5. As I move this over, I can copy and paste, and in fact, this is legitimate, right? TypeScript's not yelling at me. That's fine. It's a legitimate syntax. Or this is kind of the real syntax, right? This is, I can create that method, and again, I want to, everywhere possible, because I want to explicitly express my intent, everywhere possible, I want to put that typing information, because the more typing information I give to TypeScript, the more it can help me, right? So if I do not put this type information on here, and if I hover over this, the default is any. Unless TypeScript can use its type inference to kind of look around and see usages and everything and really figure out that it's not any, It's going to default to any. And so as much as possible, I want to say this is either a to-do or a string. And also, this wasn't on that, that other slide, but I can define a return type, right? What is my return type of this function? Is it void? Is it add to-do? Let's see, what is it? Yeah, it returns the to-do, right? So it takes in a to-do or a string, and it returns a to-do. Now we can get in here, and you can see it returns the new to-do, and we don't actually know what new to-do is. It is because it's any. But because it's any can be a to-do, so TypeScript's not going to yell at you, right? So this any can really get you in trouble. If I explicitly say, no, new to-do is a number, then yeah, now it's going to start yelling me all over. Like you can't do any of this stuff with a number, right? Now if I say new to-do is a to-do, okay, everybody's cool except for this guy. This says I'm trying to assign, when it's a string, right? It can be either a to-do or a string, this input. When it is a string, create an object out of it. Take that string, and that is the name of the new to-do. Create a new one. Can anybody guess? I kind of hovered over it real quick. Can anybody guess what this error is? What TypeScript is yelling at me? I'll kind of scroll up a little bit to give you a hint. It hasn't, so I gave it a name, but the contract of a to-do requires an ID and a completed field. So I've got two options here. I can give those, I can provide those, right? Now it's satisfied, right? If I use the wrong type, this is supposed to be a Boolean, it's going to yell at me. Nope, it's not assignable, right? It's incompatible. Or if I really wanted to do this, again, going back to the idea of this is existing code that I don't want to break just to upgrade to TypeScript, I don't want to change it. Or I can go back and I can say, this is the interface of a to-do. A to-do should have an ID, a name, and a completed field, but the ID and the completed fields are optional. They're optional because I throw a question mark on there. And so this indicates that it's optional. And so name is not optional. You'll need a name. But any object, what this means, and this is very, very different from C#, right? This is any object that has a name property can be a to-do, is what this contract says. So I can take some object that has 300 other properties and functions on it, and that qualifies as a to-do, right? So it matches kind of the meaning or the intent of the interface, not as in C# where you actually have to explicitly derive from this interface. That's not the case in JavaScript or in TypeScript. So now everything's happy here, right? Let's get into this too, because this is very cool. So this is another great example of type inference. So how many of you have written this code where you have a function that accepts multiple types, and then at some point you're going to kind of branch off and say, well, if it's this type, do this. Otherwise, if it's this other type, then do this other thing. Here is where we say, just by using the JavaScript type of, we say if type of to-do is a string. So if this is a string, triple equals or not, whatever, then go in here, right? Go into this branch of code. When we go into this branch of code, out here, to-do is a string, to-do is a string or to-do, right? Just like I defined it up here. In here, in this conditional logic, to-do can only be a string. TypeScript understands that. TypeScript knows that. And so it's going to give me the appropriate typing information, right? So when I dot into here, I'm going to get all the string methods and fields, you know, everything I can do with a string. Else, right, so if I go into the other conditional, then the opposite is true. If it was only two types and one of them was string and that was this, then the other one must be only a to-do. Right? So again, when I dot in here, this is the only stuff I can do on a to-do because I defined what a to-do is up there. So that's about it, right? Then I just kind of assign a new ID, I push it to the array, and this is all basic JavaScript stuff. So that's pretty much it. Now let's get into one more very cool thing before we actually go and convert that app. And that is this. So there's a couple things happening in this clone function here. So this is a private method. So what's going on here is, remember, keep in mind, I'm doing all of this work, all of these definitions within this function, this iffy. That's in order, and including declaring this function, right? That's why I use an iffy. That's why I do everything in a function, so that I can just create some arbitrary clone function that everybody in here can access, but it doesn't leave the context of this function that's wrapping it. If you don't understand what I just said, it's fine. Point is, it's supposed to be private, right? That's my way of encapsulating it and making sure nobody else can use it. There's also another thing going on here, which is if we look at this, and we say, we can look at this and just know that anything, it's a standard clone operation, right? You pass in an object and you stringify it, turn it into a string, and then you parse that string back into an object, right? So you do a deep clone. And it's actually, performance-wise, it's one of the most effective ways of doing it, surprisingly enough. We can tell. The humans looking at this can tell, well, obviously, if I pass this object in, I'm just turning it into a string and then putting it back into an object, the type of that object that's going to get returned, since it's a clone of the object that was sent in, is going to be the same type, especially when we're talking about TypeScript's idea of types, which is just they have the same properties, right? They look alike, duck typing. But that's not what JavaScript shows. For as smart as JavaScript is, I was actually surprised at this, right? Because any is coming in and any is coming out, that's not too surprising because that is technically the same type. But even if I say, well, let's make this specific to to-dos, right? It only takes to-dos. I clone to-dos. Even with that, the return type is any. So if I take a to-do, I stringify it, I parse it back, it's going to be a to-do that comes back out. TypeScript can't figure that out. Of course, I can go in and I can tell TypeScript, okay, fine, you want to be stupid, I will explicitly tell you, I'll express my intent, right? But now, I might as well call this method clone to-do because all it does is to-dos as far as TypeScript is concerned, but that's not true. It can handle anything. So what's another term or another way to handle anything in C#? Generics, right? So we have generics in TypeScript. And so now you've got your generic T. Works almost exactly, I get myself in trouble with statements like these, but practically speaking, it works almost exactly like a generic in C#, at least when you actually go and use it, right? So now, when we have these functions down here, let's just copy one. Get all of my to-dos that actually use this clone. Now we can see the type in there that I'm passing in. The underscore to-dos, remember, is an array of to-dos. I'm passing in that list, and I'm passing in that list of to-dos, and so it's going to return me that same type. Right? Likewise, here's type inference at work. I'm returning that. Even though I haven't defined a return type on here, if I hover over here, the return type of getAll is to-do, an array of to-dos. Just because that's type inference at work. Just because I'm returning it, TypeScript says, okay. The reason you're going, this is kind of a best practice, the reason you're going to want to explicitly say that is not to give any more information to TypeScript, it's to give more information to the other developers on your team. This is to express your intent. Even though it seems redundant, you are going to say, getAll returns an array of to-dos, because at some point, somebody's going to come in and they're going to say, right, I'm going to return something else. And at that point, the TypeScript compiler is going to yell at them and say, no, 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 no. So the developer who created this contract, this function, said that it must return an array of to-dos. You're now trying to return a string that's not assignable to an array of to-dos. Can't do that. Right? So it's now protected me from introducing that bug, either deliberately or accidentally, more likely. So that's that. Now I'm going to kind of jump ahead in time, and I've got the rest of this file that I've applied the same approach to. So I'm just going to overwrite this, and I'll kind of go through it real quick just to show there's no black magic here. I've just taken that initial to-do service, and I have just copied over all of those methods. I converted those function calls into arrow functions. Here's another very cool thing about the arrow function. This filter function, and check that out, there's really good Intellisense on just basic JavaScript stuff like an array, the filter method. The filter function expects a callback that returns a Boolean value. It actually can return anything, but it's supposed to be truthy or falsy, right? So arrow functions, in addition to doing things like taking care of this and making sure that that remains the same, you can also do without that return function. So if you just have one single, let me send this on the next line. If you just have one single line of code, not only can you do away with the brackets, you don't need brackets in there, it's just one expression, just go ahead and call it. You could also, by default, will return the result of that expression. So it's kind of a nice compact. So in other words, just to really drive this point home, in ES5, the original version of this looked like that, right? So syntactic sugar, get rid of all this stuff, and it just compresses down into this. And of course, because because TypeScript knows that the to-dos field is an array of to-dos, that Intellisense goes all the way down the chain. So filter will pass in, it requires a callback that takes in a to-do, which means by the time we get in here, I know that this is a to-do. So it's strongly typed, even several kind of jumps down, several method calls down. Okay. So that's that. That is, with 9 minutes left to go, that I've converted that one service. So now let's jump over to app. App is deliberately very simple. So the big thing with app here, when I rename it to TS, rename the file, is the very first thing that we're going to see maybe I should refresh. Hello? No? Oh. Leftovers from the old demo. Whoops. I'm going to re-add this folder in just a second. Come on. All right, well, you're getting a sneak preview of what you're going to see or how to fix it. But the first thing you're going to see is cannot find name $. So anybody who's used jQuery, we all kind of know that this is jQuery. But TypeScript says, hey, what TypeScript sees is an undefined global variable. I don't know what this is. I can't give you any type information. So nope, you're not allowed to do it, right? But again, this is not one of those class of errors that will keep it from generating. It'll still generate the code. It'll just say, hey, I can't help you here. This is, I have no idea. There's a couple of different ways around this. The cheap way is to declare. You can just declare a variable. You're declaring that this exists somewhere else. Somebody else has done this, and it's the any type, right? So now what you've done is you've opted out of typing. You're saying TypeScript, just ignore this. It's the any type. Or I can kind of give it some type information. Well, this is a thing that has a name or whatever, right? Clearly, the JavaScript API doesn't do that. The better way to do that, I mean, you should never do this, basically. The better way to do that is to bring in type definitions, they're called. And so for every major library that you have out there, either when you bring that JavaScript file down, they will have a type definition next to it, or you can go to something called types. There's a project called Definitely Typed, which is a GitHub repository of thousands of the most popular libraries out there and the typings for them. So I'm going to go into, I'm just going to use node npm. And in my project, I'm just going to install, this is what I just deleted, this is why it was working. I'm going to install at types, if you can't read this, it's fine, jQuery, right? I'm using the jQuery library. And I'm using npm to do this, and it's going to bring this in. And just by the nature that it's in my project, TypeScript will go and see it, and it will it'll bring it in. And I'm not going to go into detail here, but here's those declarations, right? Here's where it does what I just did. And so this is basically just all of the contracts for jQuery, and it describes jQuery. So now I have full Intellisense on even these external libraries, these jQuery libraries, right? So now all of those errors go away, but not only that, I've got a couple of different things going on here. Where? Oh, well, it'll show up later. So now, again, just by the nature that this to-do service is kind of in my project, TypeScript automatically sees it. I don't really have to import it or anything like that. And once I start, do need to define it. This is a to-do service. And once I do that, you see a couple different things. This lights up and this lights up, right? Let me undo that, right? So before I did that, this is any. So when I assigned it down here later on to a to-do service, that didn't change the fact that the type of this thing was any, because I can just reassign it anytime I want, right? And so none of this stuff is lighting up. But the very second that I say that this is a to-do service, now this stuff lights up. There's two things. We're going to look at this. This is my bug, right? It actually offers a suggestion. Did you actually mean this, dummy? Right? You said clear complete, but I found something clear completed. Is that what you actually meant? Yeah, that is, right? And so I can actually I can use Visual Studio Code. It gives me a suggestion of what is the proper thing. Yep, go ahead and fix that bug for me. Thanks a lot, TypeScript. The other issue that it's complaining about is that when I created add to do, I took a string type or a to do type. That was the two types that I would accept. But the result of this jQuery expression, at least as far as the jQuery types say, is either a string or an array of strings or a number. I don't know when you're going to get a number, but that's what it is, right? And so I can now do a couple of different things. I can cast it and say, I don't care what this is returning. I'm going to take one of them. And now if I say, if I try and cast this to, I can't just cast it to anything, right? If I do that, it says, no. The type says it either returns a string, a number, or an array of strings. Neither of those three things, none of those three things can be cast to what you just said. So I'm going to give you an error. But if I choose one of them and I restrict the output and I say, I always expect this to return a string, then TypeScript says, okay, we're cool. That's one of the three things that it returns. So hopefully it does, right? And so now everybody is happy again. The last thing that I want to show here, and this is kind of the one update that I've done in this talk since 2014, is async await. So how many of you have used async await in C# to deal with parallel? Yeah, so very, very awesome. Probably one of the best C# features. It's also available in TypeScript. So async and await is a way to deal with promises, right? So an asynchronous operation that returns specifically a promise. So what's a promise? It's this, right? It's an object that is thenable, meaning it has a then function which accepts a callback. So traditionally, before promises, you would pass your callback as part of your function call. You'd say, do all this stuff, and at the end, here's the function that's going to process the return, right? And this actually is legitimate. jQuery still supports this. But the kind of new way, the cool way, is with promises. And that is, take an object back, and then when that's done, then execute this call. So now I can convert this with async await to just await this thing. And then just delete these lines, right? All of this code is now just kind of inline. And now it's going to yell at me that the await expression is only allowed in an async function. Okay, that's fine. I'm going to do that. Now it's going to yell at me and say, hey, you said in your options that you're targeting ES5. Async is not an ES5 compatible thing, and I don't have the ability to kind of polyfill that off the bat, right? So you're going to have to do something. The something that I'm going to have to do is say, okay, and it tells me this. Make sure you have a declaration for the promise constructor or include ES2015 in your lib option. I'm going to go to my lib, not in here. Go in the compiler option. And I'm going to use ES2015. So all this is doing is bringing in the typings for ES2015. So what this is saying is I'm using ES5, so I'm still targeting ES5, but then also assume that the browsers that I'm targeting have the ES2015 libraries, or I'm going to bring them in or something, right? Telling TypeScript, assume the ES2015 libraries, the APIs are there through one way or another. Either they're there in the browser or I'm bringing them in. Once I do that, that error goes away. TypeScript's happy to say, okay, cool. The browser knows about promises. We're all good. And now all of this code works. So that is it. That is converting my application. I'm not going to bother showing it running because it looks exactly the same. I've just got a couple of slides at the end here, and we're done. So The last thing I want to pitch is Tech Bash. This is a new conference, so it's not that new anymore. This is actually the 3rd year that we're doing it this year. It's in the Kalahari Resort in Pocono Mountains. And this year we're actually adding a full-day pre-con, so the day before with a whole bunch of full-day sessions, so it should be pretty awesome. So check out techbash.com. And then here is all the links to the slides and everything. So thank you very much for coming. I hope that you found this informational at least, if not hopefully mildly entertaining. I got a minute or two for questions, but thank you very much. I honestly don't know. So the couple of things that I cut out of this talk for time are, oh yeah, okay, so the browser, oh cool, good, 15 minutes for question. So the question was, which of the browsers support? So there's a couple of different sites. So there is caniuse.com, which talks about the current today browser support, right? So you can say, come in here and say, I want to use Promise. So promises, here's all the browsers that are out there, all the versions that we're tracking, here's all the support, right? Surprise, IE11 doesn't support it. But everybody else does, so there you go. So this is built in, right? So this is where you can say, well, I'm using, I don't know of any good example, but ES5, right? But plus the promises APIs, which are available pretty much everywhere. Right? So I'm guaranteed that my ES5 code will run in all of these places, but all of these places, except for IE11, also have the promises in there. So let's just say that it's there. The other thing that I mentioned earlier, which I generally have a link to, but let's see if I can Google it. There is that graph, that chart that talks about, that compares the different versions. So there's, can I use, oh shoot. Darn, I don't have a link. So kind of similar to can I use, but for the actual transpilers. Can't believe it's not coming up on the first page. Chris, do you know what I'm talking about? Yeah, Chris isn't paying attention. That's what it sounds like when you listen to me, huh? Are there any other questions online or anything? Oh, yeah. So that was in the slide, so that's right here. So the GitHub site, the TypeScript intro, Jess Chadwick's TypeScript intro, that's the code. So that has the beginning state and the end state. They're in different branches. Yeah, TypeScript, you know that chart that says like Babel and all the features, and then TypeScript and all the features? Yeah, so I kind of talked about that here it is. I kind of talked about that real quick. So the only two things that I used were, what you need is an editor, a text editor. I'm using VS Code, and the transpiler, or the TypeScript transpiler. So that I was showing the command line, the TSC, but Visual Studio, if you use the Visual Studio plugin or Visual Studio support, what Visual Studio will do will install TSC and then shell out to it in the command line behind the scenes, right? So it depends on your IDE, what kind of like integrated support you're going to get, but the tool is the TypeScript compiler, TSC, compiling the text files that you've edited. Right? That's really all that you need. The one tool that I did use for the types, let's get into that since I have a couple more minutes, the Definitely Typed project. So even though it's not really straightforward, when I went and did npm install @types jQuery, that @types is an npm organization that is basically, not basically, it's a compiled, a packaged version of all of these types. So if I zoom in here, we see this is if you look at the first one. Sorry, we had to truncate this directory to 1,000 files because there are 3,200 entries in it, right? So This is a directory, a single GitHub project of 3,200 projects out in the wild with typings that are handled through here. Every single one of these projects, when a new one is added or updated, will recompile and update that npm package. It'll update the NuGet package, I believe. I don't know, I haven't used it, but I believe these also produce NuGet packages. So if you're using Visual Studio, you can bring in NuGet. But ultimately, it all comes down to this DTS that I showed. I'm just picking one at random, kind of off script here. They're all going to kind of look like this. This is a very simple one. This literally defines one function, right? But it declares things, exports things. But these are like the header files, like in C++. You know, these are like header files. They just define the contract, not the implementation. So you get the implementation somewhere else. That's up to you. So where I got the jQuery library, maybe I got it from npm, maybe I downloaded it from the site, whatever, right? But this just describes that library. I also very quickly mentioned that for a lot of projects, since TypeScript is getting more and more popular, a lot of projects are just including these .ts, these definition files. They're just including it in their solution. And so when you go to npm or wherever you get your scripts and you say install, good example, I don't know one off the top of my head, but install my favorite library. My favorite library likes TypeScript too, so they actually include that. That's all you need to do. You don't need this additional step of now also go and install the types and get the types because it came down with the library. So the key is this DTS, this declaration file that defines everything in there. This is that table. This goes back to the very, very, very first slide that I showed where I talked about one of the two things that TypeScript is it supports types, but it's also a transpiler all in one. And so this is the kind of options at the top. This is the matrix of the different compilers and polyfills and kind of the browsers, right? So this is a combination of can I use and the tools that combine to kind of show you the current state of this is ECMAScript 6, 2016 plus, next, blah, 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 right? There's a couple of different things. So we can say ECMAScript 5, ECMAScript 6. So we say TypeScript plus core.js, Babel, Tracer. So Babel and Tracer and Clojure and ES6 shim are the kind of the competitors to TypeScript, just in terms of transpilation as a transpiler, if you don't take into consideration types. And then on over here, all the kind of browser support. Like this is basically, you know, can I use, along with Node and everything, servers, runtime. So this is a pretty cool site. As you could tell, since I forgot where it was, I don't use it a whole lot, but it's very interesting to kind of see where things are supported and to kind of compare those compilers, right? So when I said TypeScript was almost as good as the others, yeah, it is, right? So it's got 59% of the support, whereas Babel 6 and 7 have 71%, right? So if you're just looking for transpilation, maybe Babel is your go-to, right? And what this refers to, the 71%, is of the total number of officially approved ES6 features, ES6, because that's what I chose here, the total number of officially approved ES6 features that are implemented by this transpiler. So TypeScript doesn't support everything that Babel does, but it's better than Tracer at 56%. And if you go down, you know, what are we talking about? You can go down to each line and you can see, hey, there's red here, right? So TypeScript does not support generators, but the other ones do. They have 24 out of 27. I don't really know exactly what that's referring to. But they have various levels of support for this feature, right? And so if you dig into these things, you can kind of get more information. This is what the 24 of the 27 refers to. And so you can see broken down to all of kind of the aspects of this functionality. What does it support or not, right? You can really kind of go down a rabbit hole. Any other questions? Yeah. Had 2 TS. You can, so you can. You can, at least you could in the beginning. I haven't used it because kind of the best practice is don't just use TypeScript as your transpiler. And then after that, you can minify, bundle, and everything however you want, right? Just use it to convert TypeScript to JavaScript. And from there, use your JavaScript and send it into your pipeline just like all your other JavaScript. Tree shaking, bundling, minification. TypeScript is a single purpose tool. Just let it do that and then bundle separately. Since I do have time, the other thing that I did not show is a couple other configuration options. Here's a very, very cool one. It's called source maps. How many of you are familiar with source maps? It's not a TypeScript feature at all. Source maps. So you probably are familiar with source maps, you just don't even know it. So source maps are not a TypeScript feature, they're actually a browser feature. Let me run the TypeScript compiler again. So now I added the source maps, option here, and what happened was it produced this new file. So I've got my JS and I've got my js.map. This is not for me, but if I look through here, I'm going to see a whole bunch of metadata that is just unintelligible to humans, right? It's unintelligible to humans, but when I refresh the page, I don't have my application running. What is it, port 5500? What this does is when I go into my developer tools in the browser and I look at my sources and I refresh the page, I see my JS file. So this is the converted file that TypeScript converted and came down and the browser is actually running. But you can actually see Chrome says, hey, I detected a source map. That's because if I go all the way down to the bottom, TypeScript added this little thing. It says, for this file, here's the source map for this. This is browser. This is a browser directive. It's telling the browser this is where to go to the source map. And through that source map, the browser is now able to recreate my TS file. And now I can set debuggers in my TS file, and I can debug my code directly, my TS, not the transpiled code, but let's add one. All right, so I put a breakpoint, and there we go, and I've got full kind of debugging and Intellisense in my browser, right? I can see my call stack, my watches, all of this stuff. That's source maps. It's not TypeScript specific, the concept, because any transpiled language or any transpiler can create those things. You can even create them for CSS. So if you're minifying your CSS or whatever, you can include a source map for the CSS. You can actually split it back out again and see in your actual source file, where does this rule live, not the minified version. So that's one feature. The other feature is you also have the option to produce declarations. So if you are creating, you should just be able to save this, reproduce it. Yep, there we go. So it created the DTS. So if you're creating a library that you plan to distribute, and so you're going to distribute the minified bundled version separately from the declarations, and you want to have just like jQuery or whatever, you can produce the declaration files. So this is what you would, if you're producing your own third-party library, you would go and create in that definitely typed repository, you go upload this for your library, and this describes your library. So now you can see it goes through and it derives, it picks out everything that everything that I'm using. In fact, my to-do service is bigger than this, right? I've got more stuff, but this is the only stuff that I'm actually using. So TypeScript goes and it kind of shakes everything else out. And now either I can have TypeScript continue to produce this, or I can do things like, well, that's why it's not producing it, because it doesn't see it. There we go. That's why it's producing it. Now I can go through and I can apply accessors to say, hey, private, internal, right, and that will affect what is produced here. What? How did that happen? Oh, yeah. What's going on there? That's interesting. I don't know what that's talking to, but anyway. So private, protected. I think it's not letting me use internal because this is not technically a module, which is something I didn't even get into, because you don't need to know it. When you do need to know it, you'll be able to learn it very, very quickly if you understand all this stuff. So with one more minute left to go, anybody else have any questions? Oh, yeah, I can bring that back up again. Oh, this guy, the initial one. Yeah, so that's that. I mean, that's my email address. I don't actually blog that much. Which one? There's TechBash. There's this. So this is the code. That's the GitHub. Yep. That's the GitHub repo. TechBash. There's all the And so you definitely want to check out this book. It's free. I'm not selling you anything. It's actually got a slider, and it says, how much do you want to pay him? Do you want to pay him $15? You want to not pay him anything? I don't care. Go ahead, grab it for free. So thank you very much for coming. Hopefully you found it informational.